Welcome to EDU World Space.
In this question, we have a regular tetrahedron, and we want to find the moments of P about edge OA, and the force P is directed along the edge BC. Okay. So to do this problem, first we need to use the definition of the moment about the edge OA. Okay, so the moment OA is equal to lambda OA, which is the unit vector from O to A, and then dots with R, C relative to O cross P. Okay. So there are three things we need to find. Okay, so we want to find the unit vector along OA first. Okay, so we are going to draw the XZ plane. Okay, so we look at the triangle OBC. Okay, and then this is where A is, and then this is 30 degrees. Okay, and then you have okay, so this is the X component of OA. Okay, and then this is the Z components of OA. Okay. So from the diagram, from triangle OBC, okay, the X component of OA, okay, is A over 2. Okay, the Z component of OA is OAX, tangent 30 degrees. Okay, put in the numbers. Okay, this is what you get, A over 2 root 3. Okay, to find OY, the Y component of OA, okay, we'll be using Pythagoras theorem. Okay, OA square is equal to OA, the X component square plus the Y component square plus the Z component square. Okay, so this is equal to A square, this is A square over 4 plus OA Y square plus A square over 4 times 3. Okay, so OA, the Y component, is equal to A square minus A square over 4 minus A square over 12 square root, and get A times 2 over 3 square root of 2 over 3. Okay. Okay, so we have the position vector of point A relative to O. Okay, so this is equal to A over 2 I hat plus A times root 2 over 3 J hat plus A over 2 root 3 K hat. Okay, so we have our lambda A O to A. Okay, so this is just divided by A. Okay, so you have half I plus root 2 over 3 J plus 1 over 2 root 3 K. Okay, then the next thing is to find the vector P. Okay, or you can first write down the position vector of C relative to O is just A times I hat. Okay, the next thing we need is the vector P. Okay, so we look at the OBC triangle again. Okay, and this is 60 degrees. right? This is A. Okay, so the unit vector BC. Okay, so from the diagram you can actually deduce that lambda BC is equal to half I hat minus okay square root 3 over 2 j hat. Okay, so how do I know that? Is that so you have, so this is a over 2, then this is a, so this length will be square root 3 over 2a. Okay, since we are only interested in the unit vector, it will be half I hat minus square root 3 over 2 j hat. So the vector p will be p, the magnitude of p, times the unit vector bc. So you have p over 2 I hat minus root 3 j hat. Okay, now we are ready to use the definition. Okay, so recall that MOA is equal to lambda OA dot R C slash O cross P. Okay, so you can choose to do the determinant method, but because RCO is there's only one term, so I think it's okay to just do the cross product directly. Okay, so you have a I hat cross P over 2 I hat minus square root 3. This is not J hat, this is K hat. Okay, yeah, sorry. Okay, so it's along the Z direction, so it's K hat. Okay, alright, so when you do cross product, I cross I gives 0, so you only look at I cross K. So I cross minus K gives J. Okay, so you have A P over 2 times root 3 J hat. Okay, and then lambda OA dot R C slash O cross P is just equal to okay, half I hat plus root 2 over 3 J hat plus 1 over 2 root 3 K hat. Okay, this whole thing dot with A times P over 2 square root 3 J hat. Okay, right, so only the J component survives, so you have A P over 2 times root 2. Okay, so you get AP divided by root 2. Okay, therefore MOA is equal to 1 over root 2 A times P. Okay, so this is the answer for this question. Okay, that's all.